Find out the Fourier transform. Find out the Fourier transform of xt given below. So xt is given as sine at divided by pi t. So xt is a type of sinc function. xt is a sinc function. xt is given as sine at divided by pi t. So find out the Fourier transform of xt. Let us solve this problem. So when we are going to solve this problem, then we can apply the duality property. We can apply the, so to solve this problem, we can apply the duality property. We can apply the duality property. So what is the duality property? So we can apply the duality property. So as we know that we have solved the previous example, that when we have xt, if we have xt, take it as pt. So if there is a pulse pt that is equals to 1 for minus a is less than or equal to t less than or equal to 1, if we take the pulse, pt, from minus a to a, we have the value 1 for the pulse pt, and it is equals to 0 for modulus of t greater than a, then the Fourier transform of this is p omega, that is equals to 2a sine a omega divided by a omega. So this is the Fourier transform of this pulse pt. So this pulse pt has Fourier transform 2a sine a omega divided by a omega, and that is equals to sinc pulse, and it is a omega equals to 0, then plus minus pi, then plus minus 2 pi. So 0 crossings are 0, plus minus pi by a, plus minus 2 pi by a. So this is pi by a, this is 2 pi by a, and at omega equals to 0 we have 2a minus pi by a minus 2 pi by a minus 3 pi by a. So this is the sinc pulse. Now we can observe that the Fourier transform for this pulse is this sinc function. So pt has Fourier transform p omega. So let us discuss this, that pt has this Fourier transform p omega. So if we find out if we replace omega with t, then pt, if we find out that capital T is the Fourier transform is where p minus omega multiplied by 2 pi. So what we can observe here, that 2a sine A omega divided by A omega is basically P omega. So PT is equals to 2A sine AT divided by AT, and the Fourier transform is equals to P minus omega multiplied by 2 pi. So sine AT divided by pi t, the Fourier transform is if we find out that sine AT divided by pi t means if we multiply with pi, then it is, and a will cancel out, so it is equals to simply, and this 2 pi will cancel out with 2 pi, then it is equals to simply, it is equals to P minus omega. And what is P minus omega? So this is P minus omega, that is, since it is an even function, it is equals to P omega. So from minus a to a, the value is equals to 1. So let us summarize this. So we have PT, this is small pt, and from minus a to a the value is 1, and the Fourier transform is P omega this is pi by a, this is 2 pi by a, this is minus pi by a, this is minus 2 pi by a. Now this is in frequency domain, so if we just replace with omega with t, then it is 0, here 2a, this is pi by a, this is 2 pi by a, this is minus pi by a, this is minus 2 pi by a. So if we find out the Fourier transform of this signal, just we have replaced omega with t here, then the Fourier transform will be equals to P omega, P minus omega, that is equals to P omega, because it is an even function and it is 1 from minus a to a on omega axis. So this is basically we have applied the duality property. We have applied the duality property here. We have applied the duality property here. So sine AT divided by pi t has Fourier transform is equals to simply, it is equals to simply P omega, and P omega is given here. So this, by using the duality property, we have find out the Fourier transform of sine AT divided by pi t. Now let us discuss the another problem. So let us find out the Fourier transform. Find out the Fourier transform of ext, that is equals to 1 divided by a square plus t square. Find out the Fourier transform of ext, that is equals to 1 divided by a square plus t square. So let us start from this e raised to the power minus a modulus t. The Fourier transform is equals to 2a divided by a square plus omega square. Now applying the duality property 2 square plus, if we replace omega with t, then if we find out the Fourier transform, then it is equals to 2 pi e raised to the power minus a minus modulus of omega. So that is equals to 2 pi e raised to the power minus a modulus of omega. And if we divide both sides by 2a, then it is equals to 2 pi divided by 2a. So finally we are getting pi by a e raised to the power minus a modulus of omega. So 1 divided by a square plus t square, the Fourier transform is equals to pi divided by a e raised to the power minus a modulus of omega. Let us discuss another problem. So find out the Fourier transform of periodic pulse train. The next problem is find out the Fourier transform of periodic pulse train. Find out the Fourier transform of periodic impulse train. Let us find out the Fourier transform of periodic impulse. So the impulse train we can draw as, since it is periodic, so let t naught is the time period after which it is repeating. So after a certain time period, that is t naught, so t naught is the time period. So after t naught time period it is repeating. So after t naught time period, del t naught t is repeating itself. So basically that's del t naught t, we can write it as summation n is equals to minus infinity to plus infinity del t minus n t naught. So after t naught time period, it is repeating. Now we can represent this in terms of complex Fourier series coefficient. Since it is a periodic signal, so it is k is equals to minus infinity to plus infinity. It is ck e raised to the power jk omega naught t, where omega naught is 2 pi divided by t naught. Now what is ck? Ck is 1 divided by t naught minus t naught by 2 to plus t naught by 2 del t minus jk omega naught t dt, because from minus t naught by 2 to plus t naught by 2 we have only del t. So it is equals to 1 divided by t naught. So we have seen in previous example that it is del t. By using the sampling theorem here, sampling property, it is del t only, so it is t naught. So ck is equals to 1 divided by t naught. So del t naught t is represented as summation k is equals to minus infinity to k is equals to plus infinity 1 divided by t naught e raised to the power jk omega naught t. Now we can find out the Fourier transform. So taking Fourier transform on both sides, taking Fourier transform on both sides. So Fourier transform of del t naught t is equals to Fourier transform of 1 divided by t naught summation k is equals to minus infinity to plus infinity e raised to the power jk omega naught t, and that is equals to 1 divided by t naught summation k is equals to minus infinity to plus infinity Fourier transform of e raised to the power jk omega naught t, and that is equals to summation k is equals to minus infinity to plus infinity del omega minus k omega naught, omega minus k omega naught. So the spectrum of this is this Fourier transform. The spectrum of this is, we have delta function at 1 divided by t naught, that is del omega, then at 2 omega naught we have del omega minus omega naught, and this type of spectrum we are getting. So we have for k is equal to 0 it is del omega, and that 1 divided by t naught del omega. For k1 we have 1 divided by t naught del omega minus omega naught. Here 1 divided by t naught del omega plus omega naught. So this spectrum we are getting. So this is the Fourier transform of. So further this 1 divided by t naught is, if we write this 1 divided by t naught, then omega naught is equals to 2 pi divided by t naught. So t naught is 2 pi divided by omega naught. So basically we can further write it as, since it is since 2 pi divided by t naught is equals to omega naught, so better to write it in the form of omega naught. So it is omega naught k is equals to minus infinity to plus infinity del omega minus k omega naught. So this is the Fourier transform of del t naught t, that is equals to del t naught omega, that it is del t naught omega. So this is the Fourier transform. This is 2 pi. This is also 2 pi. This is 2 pi. So the spectrum. So that's the spectrum. So basically spectrum is series of delta functions, series of periodic delta functions in omega axis, in omega axis. So let us find out the Fourier transform of, let us find out the Fourier transform of, question is a real valued signal xt, a real valued signal xt is limited to the frequency, is limited to the frequency band modulus of f is less than omega by 2. It is passed through a, it is passed through a linear time. It is passed through a linear time invariant system whose phase response is HF, that is equals to e raised to the power minus j 4 pi f for modulus of f is less than or equal to omega by 2, and it is equals to 0 for modulus of f greater than omega by 2. So what we need to find out? We need to find out the output of the system. The output of the system is, so we have ext plus 4, then b is ext minus 4, c is ext plus 2, d is ext minus 2. So let us solve this problem. So we have a linear time invariant system. HF is the transfer function, the input is XF, and the output is YF. So YF is equals to HF multiplied by XF. YF is equals to HF multiplied by XF. Now this value is given, HF is given, and HF is equals to e raised to the power minus j 4 pi f, and it is multiplied by XF, that will give us YF. So if we just carefully observe that, then YT is equals to XT minus 2, because if GT has Fourier transform GF, then GT minus T naught has Fourier transform e raised to the power minus j 2 pi f T naught into GF. So if we just compare it, then we will find out that T naught is equals to 2 for that case. T naught is equals to 2 for that case. So it is YT is equals to simply XT minus 2. So inverse Fourier transform, if we find out the inverse Fourier transform of this signal, then it is XT minus 2 simply, and it is YT. Let us do another problem. The problem is we have a system where the input 2 by 3 is given, 2 by 3 un plus 3 is given, and the Fourier transform of this, that is discrete time Fourier transform. Basically this is discrete time Fourier transform, and that is equals to a e raised to the power j 6 pi f divided by 1 minus 2 by 3 e raised to the power minus j 2 pi f. This is provided in the question. Now what we need to find out? We need to find out the value of A. So we need to find out. So find out the value of A. So how to find out the value of A? So first, if xn is the discrete time signal, let us find out the discrete time Fourier transform for this particular signal. So if xn is a discrete time signal, then the Fourier transform, then the discrete time Fourier transform dtft of xn is given as x e raised to the power j omega, that is equals to summation n is equals to minus infinity to plus infinity xn e raised to the power minus j omega n. So xn, putting the value of xn, it is summation n is equals to minus infinity to plus infinity 2 by 3 raised to the power n un plus 3 e raised to the power minus j omega n. This is x e raised to the power j omega. So x e raised to the power j omega is written as summation n is equals to minus infinity to plus infinity 2 by 3 raised to the power n un plus 3 e raised to the power minus j omega n. Now if we just carefully see that, we will find out that it is from minus infinity to minus 3 to minus infinity. It is 2 by 3 raised to the power n into 1, because un plus 3 is equals to 1 for n greater than or equal to 3 minus 3, and it is equals to 0 for n less than minus 3. So minus 3, minus 2, minus 1, all values of 1, it is equals to 1, and it is 0 for all these values. It is 0 for all these values. So now if we just make some slight adjustment, we take k, that is new variable, that is k is equals to n plus 3. So it will become summation k is equals to 0 to k is equals to this is plus infinity, this is plus infinity, infinity 2 by 3. Instead of n, we are writing k minus 3 e raised to the power minus j omega k minus 3 we can write. So what we are getting here, k is equals to 0 to k is equals to infinity 2 by 3 raised to the power k 2 by 3 raised to the power minus 3 e raised to the power minus j omega k e raised to the power j omega 3. So what we are going to get is 2 by 3 raised to the power minus 3 e raised to the power j3 omega summation k is equals to 0 to infinity 2 by 3 raised to the power k e raised to the power minus j omega k. So this x e raised to the power j omega, we can write it as x e raised to the power j omega, we can write it as 2 by 3 raised to the power minus 3 e raised to the power j3 omega summation k is equals to 0 to infinity 2 by 3 raised to the power k e raised to the power j minus j omega k. Now if we solve this, what we are getting here, 2 by 3 raised to the power minus 3 e raised to the power j3 omega 1 divided by 1 minus 2 by 3 e raised to the power minus j omega. This is x e raised to the power j omega. Now if we compare, we will find out that if we compare with that question given, we will find out that a is 2 by 3 raised to the power minus 3, and that is equals to 3 into 3 into 3 divided by 2 into 2 into 2. So it is equals to 27 divided by a, and a is equals to 3.3375. Please check, is it correct or not? So it is a is equals to 3.3375. Please check this calculation. Thank you. Now let us do another problem. So find out. So let gt is given. And it is equals to e raised to the power minus pi t square. So and let gt is given, let gt and ht is filter. HT is basically the impulse response is filter matched to GT. So basically it is a type of match filter. It is a type of match filter where the impulse response HT will matches with the input signal GT. So if GT is applied, if GT is applied as input, if GT is applied as input to HT, then the power transfer, if HT is applied as input to HT, then the Fourier transform of the output is, we need to find out the Fourier transform of output. So we have a signal that is GT, the impulse response is FT and HT, then output is YT. So we need to find out the output YT. So according to the definition, YF should be equals to HF multiplied by GF. So what is HF? So HF is Fourier transform of HT. What is GF? GF is Fourier transform of GT. What is YF? YF is Fourier transform of YT. So HF is Fourier transform of HT, GF is Fourier transform of GT, YF is Fourier transform of YT. So this is basically that equation. Now GT is given, GT is exponential minus pi t square. Now we need to find out GF. So GF is exponential minus pi t square. The Fourier transform is exponential minus pi f square. This is the famous Fourier transform relation. So this property is that this Fourier transform pair is that if we have minus pi t square, the Fourier transform is equals to exponential minus pi f square. So basically if we have a Gaussian, what it says that if we have a Gaussian, pulse, then the Fourier transform of this is also Gaussian. The Fourier transform of this is also Gaussian. The Fourier transform will also Gaussian. So since GF is exponential minus pi f square and HF is also exponential minus pi f square, because it is matched to GT, because HT is matched to GT. So both have same Fourier transform. So YF is equals to exponential minus pi f square multiplied by exponential minus pi f square, that is equals to exponential minus 2 pi f square. So YF is equals to exponential minus 2 pi f square. Let us solve another problem. So a function is given by ft is equals to sin square t plus cos 2t. Now we need to find out. So find out the frequency components of ft. So ft is given as sin square t plus cos 2t. st is given as ft is given as sin square t plus cos 2t. Now it is written as sin square t is written as 1 minus cos 2t divided by 2 plus cos 2t. So it is equals to 1 by 2 plus cos 2t minus cos 2t divided by 2. So that is equals to 1 by 2 plus 2 cos t 2t minus cos 2t divided by 2. So 1 by 2 plus cos 2t divided by 2. So this is equals to ft. So this is equals to ft. Now what we are going to find out that we have two components. First component is 1 by 2, so this is DC only. Second component is cos 2t by 2, so the frequency is 0 for DC component, and another frequency is pi hertz. So this component will give 0 hertz, and this component will give us 1 divided by pi hertz. These are two frequencies present. Let us do another problem. So let xt is provided and let it is equals to x e raised to the power j omega. The Fourier transform of signal x 5t minus 3 in terms of xj omega is given as. So let us find out that solution. So x 5t minus 3 is written as 5 t minus 3 by 5. So it is simply we can just write as a t minus t naught, where we have t naught is 3 by 5 and a is equals to 5. So here what we are going to do, this is the delay we are providing, this is the delay and this is the scaling. So first we have provided the delay and then after that we have scaled. So let us first find out xt minus t naught. So the Fourier transform of xt minus t naught is e raised to the power j 2 pi f t naught into xf. After that, when we are going to scale, then the Fourier transform will be equals to 1 divided by modulus of a. Instead of writing f, we are going to write f by a. So it is e raised to the power j 2 pi f by a t naught into x f by a. So the solution is very simple. So it is putting the value of a and put t naught. What we are getting? We are getting 1 divided by 5 e raised to the power j 2 pi f 3 by 5 x f by 5. So instead of writing f, we are writing, if we are writing omega, then it is simply x j omega. It is equals to 1 by 5 e raised to the power j 2 pi f is omega. So 3 omega divided by 5 x j omega divided by 5. So this is the solution. This is the solution. Instead of 2 pi f we have written omega. So it is 3 omega 3 divided by 5 x j omega divided by 5. This is the solution. Let us do another problem. So the problem is find out the Fourier transform of. So the Fourier transform is given as the Fourier transform is given as e raised to the power minus t. The Fourier transform of e raised to the power minus t into ut is given as, suppose this is xt, is given as 1 divided by 1 plus j 2 pi f. So the Fourier transform of xt is given as 1 divided by 1 plus j 2 pi f. Now we need to find out. So find out the Fourier transform of 1 divided by 1 plus j 2 pi t. Find out the Fourier transform of 1 divided by 1 plus j 2 pi t. So let us discuss this problem. So e raised to the power minus t into ut, the Fourier transform is equals to 1 divided by 1 plus j 2 pi f. Now instead of f, if we take t, then 1 divided by 1 plus j 2 pi t, then we can apply the duality property. So here what we will get? We will get e. Instead of t we have to write minus f. Instead of t we have to write minus f. So it is equals to e raised to the power f u minus f. Let us solve this problem. Let xt be the input. Let xt be the input to a linear time invariant system. Be the input to a linear time invariant system. The time invariant, the required output is 4xt minus 2. This is the required output. Now we need to find out. So this transfer function of the system should be the transfer function of the system should be. So we need to find out the transfer function of the system. So the output is given, yt is given, that is equals to xt minus 2. So the system is, this is LTI system. The impulse response is st, the input is xt, and the output is yt. So yt is related to xt convolution with ht. Then yf is equals to xf convolution with hf. So yt is given, that is xt minus 2. Yf is e raised to the power minus j 2 pi f into 2 into xf. So hf, that is yf divided by xf, is equals to e raised to the power minus j 4 pi f. So the transfer function hf is e raised to the power minus j 4 pi f. This is the transfer function. This is the system transfer function. So it is 4 here. Now let us discuss another problem. Let us discuss the problem that is related to Gaussian pulse. So the problem is the Fourier transform of signal xt is equals to e raised to the power minus at square is of the following form, that a is given as, that a part is given as a e raised to the power minus b modulus of f, b is given as a e raised to the power minus b f square, c is given as a plus b modulus of f square, d is given as a e raised to the power minus b modulus of f. So let us solve this problem. So the transfer function is given as xt is equals to e raised to the power minus at square. So we can apply that scaling property here. We can apply the scaling property. So we know that Fourier transform of minus pi t square is equals to minus pi f square. So this term we can write it as exponential minus pi t divided by under root pi by a whole square. Actually we need to write this exponential minus at square, we have written in this way, so that we are able to calculate here, we are able to calculate that Fourier transform, and that is we are providing scaling that is equals to basically, so e raised to the power minus pi, basically that we are providing scaling, or what scale factor we are providing, that is scaling of under root a by pi. So it is equals to 1 divided by under root of a divided by pi. This is the scaling we are providing, and exponential minus pi, instead of f we are writing under root a by pi. So the Fourier transform is basically, we have the form of Fourier transform is a e raised to the power minus bf square. This is the form we are getting, so this is the correct answer. Basically what we have done here, this exponential minus pi t square, so basically we need x in this form, minus pi t square form. So xt is given, that is equals e raised to the power minus a t square. So what we are going to do, we have just written exponential minus pi e raised to the power minus pi a t square divided by pi. Then after we have written in this form minus pi under root a divided by pi into t square. So it is nothing but exponential minus pi kt square. So what we are going to do here, we have a scale variable, that is a divided by pi. We have provided a scaling. So when we are going to do scaling, then if gt has Fourier transform gf, then gat has Fourier transform 1 divided by modulus of a gf by a. This is the Fourier transform. So this exponential minus pi t square has Fourier transform exponential minus pi f square. So when we are providing scaling, then the Fourier transform is 1 divided by scale factor, that is k exponential minus pi f divided by scale factor, that is, so it is of the form this form, a e raised to the power minus b f square. Let us solve another problem. So the problem is a signal xt has a Fourier transform x omega. A signal ext has Fourier transform x omega if xt is real and odd. If xt is real and odd, if xt is real and odd function of t, real and odd function of t, then x omega is, there are various options, a real and even function of omega and even function of omega. The b part is an imaginary and odd function of omega, an imaginary and odd function of omega, then an imaginary and even function of omega, and imaginary and even function of omega, and d is a real and odd function of omega, a real and odd function of omega. So let us solve this problem. So the problem is, we have a signal xt that is real and odd. We have a signal xt that is real and odd. Then what we are going to do here, let us take an example, that is xt is equal to sine omega naught t. So this is real and odd. Now x omega, if we find out the Fourier transform xf, then it is equal to 1 divided by 2j del f minus f naught plus del f plus f naught, or in terms of omega it is written as 2 pi divided by 2j del omega minus omega naught plus del omega plus omega naught. So it is basically imaginary and odd. It is basically imaginary and odd. So it is basically imaginary and odd function of omega. It is imaginary and odd function of omega. Let us discuss another problem. So the problem is, we have the Fourier transform of, the problem is the Fourier transform of voltage signal xt is xf. The Fourier transform of voltage signal xt is xf. This is provided. The unit, we need to find out the unit. The unit of xf is, we need to provide the unit of xf. So xf is equals to minus infinity to plus infinity xt e raised to the power minus j 2 pi ft into dt. If we just carefully see that, then unit of xf is volt second. Unit of xf is volt second, that is volt per hertz. So the Fourier transform, the unit of xf is volt per hertz. Let us discuss another problem. Let us discuss another problem. The problem is the value of integral. We need to find out the value of integral. The value of integral minus infinity to plus infinity sec square t dt. We need to find out the value of this integral. So for solving this type of problem, it is very difficult to integrate, because if we draw the sinc function, so if we draw the sinc of x, then we find out that this is the graph of sinc x. It is very difficult to integrate the sinc function. It is very difficult. So what we are going to do, we are using the Rayleigh theorem. So what is the Rayleigh theorem? So the Rayleigh energy theorem, let us apply the Rayleigh energy theorem. So the energy of this signal, if we consider the Rayleigh, that is equal to minus infinity to plus infinity modulus of gt whole square dt. That is also equal to minus infinity to plus infinity modulus of gf square df. Both are same. The energy will be. So what we are going to do, if we find out the Fourier transform, then we can find out easily that solution of that problem. So we know that a rect t by t has Fourier transform is equals to at sinc eft. So this rect is let it is pt. So this pt, that is rect function, that is defined from minus t by 2 to plus t by 2. The value is a, and here we have sinc function, so it is in f domain, so it is at here. Then we have zero crossings, these are zero crossings. So this is Fourier transform pair. Now we can apply the duality property. So according to this property, if we have at sinc tt, instead of f if we replace with t, then that is equals to a rect minus f divided by t. So that is equals to a rect f divided by t. That is the Fourier transform of this signal. So this signal has Fourier transform a rect f divided by t. Now this at we can take here. So this sinc T capital T, this is equals to A divided by AT rect F divided by T, that is equals to 1 divided by T rect F divided by T, and this is equals to sinc TT. So if we just carefully see that, then capital T is equals to 5. So and this rect function is from minus t by 2 to plus t by 2, that amplitude is 1 by t, and that is equals to 1 by 5. So it is equals to 2.5, it is equals to minus 2.5 because t is equals to 5. So if we find out that minus infinity to plus infinity sinc square t dt, that is also equals to minus infinity to plus infinity, the Fourier transform of this, that is 1 divided by 5 rect f divided by 5 square into df, and that is equals to if we just see that what is the area of that, the area is basically 5 multiplied by 1 by 5. So this area basically what we are going to find out the area of this. So it is simply 1 divided by 5 square, then from minus t by 2 to plus t by 2, so it is 5, so it is 1 divided by 5, so it is basically we are getting 0.20. So that solution of this is basically we are getting 0.20. This is the solution.